Well, hello everyone. This is Vesper HPT, just doing a little update on my rotor. Had a little mishap earlier today, and well, actually last night. I over-revved one of the rotors, and this is a replica of the other rotor that I'd originally made. This rotor right here is defective. The polymer that I used for this basically causes fractures when it gets its speed. The forces that are applied to it basically make it explode. To be simplistic, so I can't ever use this rotor. It's just basically for showing purposes now. But I've went ahead and changed the polymers, and I made this rotor. This rotor is a little bit different. There's several modifications that have been done. If you notice here, there's a fin that's in between the axial part of this rotor. If you look at that, there's this fin. If you look here, that fin has been completely removed. The reason for that is because of the deflection of the actual pulses that go on inside the motor. It was causing a fracture point to actually cause and happen right through this area here because there was no deflection in this. Granted, it may not be enough that we can see it, but it was causing some problems. And so I redid my computer model and found that the way to get rid of that is twofold. One was to remove the lip or the fin that was in here. You'll notice that it's still okay in the top because the angle actually takes the stress off of it. But the fin has been removed. And then if you look here, you'll actually see like a groove. Let me get a little bit closer, kind of a side profile there. You can see that groove that's there. And that groove is so that when I put my magnets in, I can clamp this down slightly. And when I clamp that down, I get them to glue in place, and it takes just a little bit of stress off this outside edge from when they're pulsing, and it places it inside the barrel rather than the actual outside. You'll notice that the difference in material. This one is more of a flat type material. It's just got a different polymer. This polymer actually makes it so that it's shiny, and makes it just a little bit easier to get out of my molds too, which was an added benefit, one that I didn't know that I was going to have. If you look at the top, this is where my magnetic bearing is. I talked about that on my first video. And all of these, the upper set as well as the lower set, all still have their fins in place. And again, that's because the angle, it's okay for those to have the fins, and it actually adds a little strength to the bearing mechanism up here. There is a fin that's actually attached to here on two places so that it takes the stress off of the top here. Now, I'll take this one apart. It just takes a second so I can unthread it, but I'll take this apart so you can see the inside. And that's important because that's actually where my drive coil is going to be, or my pulse coil. Everything that you see on the exterior, these are all going to be slave coils, and that's just to develop a power source or excess power to come from the circuit. So if I take this off, again, you'll notice that the interior is hollow, and you can see right down here at the bottom, you can see my finger kind of going across it. That's where the bearing is, and then you can see that it's a hollow unit. And those are the outside, and then of course you can see a real good cutaway version of how those fins have been removed. Now, if you look here, this blue disc that I have in here, this is a different type of plastic that I've came up with for isolating the current in the coil so that it doesn't cause magnet transfer or pulse transfer between the other coils that I'll have in here. Because it's such a close space in here, the dimension here is only about 3 3/4 inches across on the inside. So it's a very tight section that's in here. and then just the nut that holds that in place. And this disc will actually be centered. If we go down here on the edge, you'll see it'll be centered in this hole here, which is where the magnet will go, and you can see the little retaining lip that's there, and that gives me my proper gap between where the coil will sit and the edge of the magnet, so that we get proper pulsing that happens. And if you look here, if I rotate the exterior or the rotor, you'll notice the interior is completely separate. So the actual coils that'll be in here will be attached to this disc, and their wiring will be fed down through this rod and out the bottom here, and that's where the power will go in to actually turn the rotor on to make this whole thing rotate. So my actual drive coils will be on the inside of my motor rather than on the outside. That actually gives me 3 more coils worth of energy on the outside, because I'm going to probably have 3 pulse coils on the inside to give us rotation. I'm going to probably start out with 1 just to test the theory and test everything out, and then I'll increase that just so I can get some added speed. And that's pretty much it. I'm probably going to change all of the interior metal pieces to plastic as well. I'm working on a polymer base for this so that it's strong enough but still flexible enough to take the load on here. I've contacted a couple of polymer companies to see if they can help me out with that because of the stress load that'll be on there. It's just a little bit outside my knowledge range for a threaded piece of material that I can put nuts on and things like that. So they may be able to help me out with that. I'll go ahead and put this back together. It's pretty easy. Once all the coils and stuff are inside, this piece will just come back down. We line it up so that all the holes are there. Of course, we'll have the magnets in here that'll help us line everything up. And then from that point, then it's just good to go. And that's pretty much it. Those are a lot of the changes that have happened. And I am actually getting ready to test this unit. I'm putting actual lead weights inside of here rather than magnets, because on my first attempt with the original that was like this, it disintegrated and threw all my magnets that I had placed in here throughout the lab and caused quite a bit of damage. And most of the magnets could not be salvaged. They were pretty dented up. They can be used for other projects, but not for this one. So I'm waiting on some magnets to come in. I had to order them. So as soon as they come in, then I'll have them all placed in the new unit, and I'll show you how all of those go in a future video. And after that point, then I'll go ahead and fire it up and show you, because I'll probably have the coils in place and everything for that as well. And I hope that that's been a little enlightening and brought you up to speed on everything that's been going on. So we've remade the model a little bit different, and shown you how the disc works on the inside where the coils are going to go, and how everything's going to work. So hopefully by the time I get my magnets here in a few days, then I'll have all my coils wound for the outside, and we'll continue on from there. Thank you very much for watching. If you have any questions, please visit us on the TEEP forum, www.teepforum.com. Just do a search, you can find the TEEP forum. And you can find all the links and videos on YouTube for all of my motors. Thank you very much. Have a great time. Bye-bye.